All right, guys, today we're going to start talking about matrices, and we're going to start with a little bit of vocabulary with some examples. So first we're going to define what a matrix is. A matrix is a rectangular array of variables or numbers that are arranged in rows or columns. All right, next we're going to talk about a dimension, and in a minute we'll go back and we'll do all the examples, okay? So dimensions, you always write the dimensions as the number of rows by the number of columns. And then elements, these are individual values that are in the matrix. And then we'll talk about the notation for an element when we get our examples here. Feel free to pause the video anytime you need to finish copying things, but I'm not going to pause long enough, and that way maybe the video won't be quite so long. So to start out with an example of a matrix, you have a set of square brackets here, and there's one row, and there's my second row. So now, if I say that this is matrix A, say A equals this matrix, then the way you would write the dimensions would be A, and then as a subscript, you have 2 rows and you have 3 columns. Remember, rows go across the page, columns go up and down. So then if I wanted to talk about the number 7 and describe the location of that within the matrix, well, that element is in, we'll just call it A. It is in row 1, column 2. So the element in row 1, column 2 is a 7. All right. Moving on, we're going to do just a couple of these together, and then you are going to finish. Okay, for number 1, they want us to give the dimensions of the matrix. Well, I happen to have 1, 2, 3 rows by how many columns? So my columns, I have 1, 2, 3, 4. So this is a 3 by 4 matrix. Number 2, I only have 1 row, but I have 2 columns. So that one is a 1 by 2. Now for 5 through 7, they want us to write down what element is at the indicated position. So here, I want the element that is in row 5, column 3. So my A sub 53 is in row 5, 1, 2, 3, 4, 5, column 3 It is -7. All right, there's 2 left for you to work on. We'll go ahead to adding and subtracting matrices. Matrices can be added or subtracted if and only if they have the same dimensions. Okay, which means they have to have the same number of rows and the same number of columns. So now, you are given matrix A, B, C, and D. So what they want me to do in number 8 is to add matrix A plus matrix D. So I am going to write those down here so that they're close to each other and I'm not having to transfer, from too far away. A is -4, 15, and -10. The second row is 32, -5, -3. I want to add to that matrix D, which is 39, 20, and -13 on row 1. Row 2 is -8, 12, and -15. So your answer is going to come from adding the corresponding elements. And when I say corresponding, that means the ones in the same location will be added together. So I will start out by adding -4 and 39. That will give me, in row 1, column 1, I'm going to get 35. Now, if I slide over and I add 15 plus 20, that is going to give me 35. And then finally on the top row, I'm going to add -10 plus -13 will give me -23. That's the top row done. Now let's go ahead and add the bottom rows together. So 32 plus -8 is 24. -5 plus 12 is 7. And then last, -3 plus a -15 is -18. And that is your answer. All right, if you take a look at number 10, they want me to add C plus D. Well, if you look at C, it has 4 rows and 2 columns. D has 2 rows and 3 columns. These 2 matrices are not the same size, so this is not possible. So now, number 9 is a subtraction problem. You do it the exact same way you did the addition problem. You're going to subtract the corresponding elements, which means you'll start out with -11 minus 28. And that will give me -39. To finish out that top row, I'm going to do 7 minus -6 will give me 13. That takes care of the whole top row. You should be able to finish this one from here and then go ahead and do number 11. All right, so now scalar multiplication. We're going to do this just like we would a distributive property. Okay, here it says that multiplying all elements within a matrix by a constant called the scalar is called scalar multiplication. I just need you to remember that it is like the distributive property. Okay. All right, so we're going to use the same matrices A, B, C, and D that we used above. And we'll do two of these together, and then you can do the other one, or the other two. All right, so we're going to do number 13. And for number 13, I have to multiply -6 times matrix C. So what we're going to do is, here's my -6. It's going to be multiplied by everything that is in matrix C. So let me recopy C here. So now all I'm going to do is start with the first element on the top row, and I'm going to multiply 28 times -6, and I get -168. To finish out the top row, -6 times -6 is 36. On the second row, -6 times -12 gives me 72. -6 times -8 is 48. Move on down to the third row, and I have -6 times 17 will give me -102. -6 times 1 is -6. And on the bottom row, I will get 30 and 54. This is your answer. All right, so then what you will do next for number 15 is you will do this. You'll multiply 5 times C. This is step 1. Then you will multiply 2 times matrix B. That is step 2. And then you're going to add those two matrices together. That is step 3. All right, and I'm going to leave it at that, and you guys can let me know if you have questions. All right, so now, when you are multiplying matrices together, this is one matrix times another matrix. It's a little bit different here. All right, so let's go through this information at the top, and then we will do a couple of these, and I may need some more room to do it when it's actually time to multiply. So let's see. It says matrix A and matrix B can be multiplied if and only if the number of columns in matrix A, let's try again. Is equal to the number of rows in matrix B. All right, so if matrix A is a M by N, and then if matrix B is an N by P, then matrix AB, after you multiply them, you will end up with an M by P. So now, that last part is a little bit hard to grasp. So what we're going to do here is I'm going to explain it a little bit more in number 16. Because all we're going to do in 16 through 19 is figure out, can they be multiplied? And if so, what size or what will the dimensions of your answer be? So what we're going to do is start out, matrix A is a 2 by 2. Matrix B has 2 rows and 3 columns. I just write the dimensions down there side by side. And I want you to look at these inside numbers. Those are the same, so you can multiply. Okay, so let me write the word same here for you. Oops, can multiply. Now your answer will end up being, if you look at the outside ones, your answer is going to be a 2 by 3. All right, so then let's take a look at 18. I want to multiply R times S. So R has 3 rows and 2 columns. S has 3 rows and 3 columns. If you look at these two numbers, they are not the same. Okay, they are different. That means you cannot multiply those. All right. So now, number 21. I think I'm going to need some more room to work that. So I'm going to grab a sticky note and put in here. And then when we are done multiplying it, then I'll move it off the top of the other problems. Okay, that's the problem with these little sticky notes here, is they are sometimes in the way. All right, we'll see if this gives us enough here. I don't know if I'm right on that little or not. We're going to try it and see. All right, so for number 20, I'm going to start out by multiplying this row by this column. Now, here's what I do. I take that top row with the 5 and the -4, rotate it 90 degrees, and put my 5 next to the -1, and then my -4 next to the 4. And I'm going to multiply -1 times 5, and then I'm going to add to that 4 times -4. Okay, the things that were side by side here got multiplied. And all of that goes on the first row in the first column. Now, I have to multiply that top row by the second column. Okay, so once again, I'm going to take that top row and turn it 90 degrees and write it next to that column. And then in my work over here, I'm going to stay on the top row, but I'm going to scoot over to the right side, and -7 times 5 add to that -2 times -4. That's done with the top row. So now, let me erase all my highlights. Now I've got to move down to row 2. So I'm going to multiply row 2 times this column. Now, I'm working with row 2 and column 1. So in my work, I'm going to have to go down to row 2, but stay in column 1. Take this row, rotate it 90 degrees, and now the numbers next to each other get multiplied. So -1 times -3 plus 4 times 9. Now notice I left myself some space because I'm going to have to go back in and simplify that in a minute. All right, now that I'm done with the second row and the first column, now I have to work on the second row and the second column. So in my work, I go down to the second row, but then I move over to the second column. Okay, rotate my row, and I'm going to multiply -7 times -3 plus -2 times 9. Now we're going to go back in and simplify all of that in my work here. So this gives me -5 plus -16. This is -35 plus 8. 4 plus 36. That's positive 21 plus a -18. Finish your simplifying and you get -21, a -27, 40, and 3. So what you're going to do is you're going to take what I've got written in green. Those are your answers for each position in the matrix. So the top row is going to be -21 and -27. The second row will be 40 and 3. That is your answer. That's what you get when you multiply those two matrices together. Okay. All right, so now let's see. That's about as small as I can make it. I'm going to put it over here on top of problem 21. Oh, evidently my work didn't go too. Let's try again. Well, I don't know how to move all of that, so I'm going to leave it for just a second while you copy it. Make sure you've got it all. I may be able to move this in 2 steps. We're going to try again. Oh, actually, it did move it all that time. There we go. All right, there it is. It's just up out of the way at this point. Okay. So now you can do 21, 22, and 23. And I think we're going to leave it at that. Okay, we may come back in here another day with these video notes and finish up the flip book, but hopefully I will be here in class to be able to go over it with you. All right. Anything up to this point, up through 23, that we did not do together, it is your responsibility to finish.